introduce Professor Dilley. As you know, the weather is being used as a political tool of the left. Well, Professor Dilley is here to prove otherwise. So let's have a big hand for David Dilley.
Well, it's great to be back again. I have 37 years of research on climate, going back quite a ways, and I've developed what is called climate pulse technology. We're going to be talking about that tonight. It's based on proven science. The electromagnetic interactions between the Earth and the Sun, which control just about everything. My organization, Global Weather Oscillations, specializes in hurricane landfall predictions. We've been the #1 preseason predictor for 10 years in a row. El Nino predictions going out 2 years in advance, climate change research predictions, weather cycles, and I have ebooks on the website and about 6 videos on YouTube. If you Google my name and climate videos. So we're going to take a walk through climate change. It's going to be sort of like a murder mystery in a way. We're going to gather clues and analyze them, and at the end, put the clues together, and we'll see the whole picture. So it's going to be step by step. So it's sort of like a murder mystery, so you have to follow right along so you understand the conclusion. The topics, first one be how we got here, grants and universities, media and public views, global warming, current status, CO2 and temperature cycles, what controls the climate cycles, ocean cycles, sea level rise, and ice melt, and finally, the unexpected climate disaster. The Green New Deal, world will end in 12 years. Now, where did they get their information? 1995 through about 2017, the government grants to universities were only awarded to prove human activity as the cause of global warming. And for the rise of carbon dioxide and global warming. That's the only grants you could get. Absolutely no grants were available to study natural climate cycles. If someone at a university tried to get a grant or wanted to do something on natural climate cycles, they either lost grants or couldn't get grants and were told to shut up. So climate change grants had become the university's bread and butter. To get the bread and butter, they have to apply for certain grants and they have to talk about what the grant wants. That's human-induced global warming. End result, all science journals only publish, or not all, but most of the science journals only publish research that showed human activity as the primary cause for climate change. Studies out there on natural cycles. So they only got what was fed to them through the journals, which was not good use of grant money. So then because of that came the manipulation by the media, because this is the only information the media got. Then the media, of course, turned it around. They had the activist groups, teaching skewed science to our young students. And the climate alarmists use fear and deception. We know that very well. That's to achieve their goals, no matter what. We have all heard about 97% of all scientists believe that humans cause global warming. We've all heard that, right? Do you believe it? You already know the answer here. Well, what they looked at was Dr. John Cook, University of Queensland in Australia. He looked at just about 12,000 abstracts of research papers. The research papers that mentioned climate change. Of the 12,000 papers, 33% of them said that human activity is the primary cause. That's 33% of them. So Dr. Cook sent letters out to that 33% and said, will you endorse by mail that you believe that humans are the primary cause? So what happened was 97% of the 33% wrote back and said yes. That's where the 97% came from. Remainder of the papers, almost 8,000 of them, which is 67%, had no opinion or found no connection to human activity. Associated Press, of course, has taken all this stuff, and their polls now say that 74% of all Americans believe that climate change is caused by humans. So let's get back to reality. A poll taken by Dr. John Coleman, he was the founder of the Weather Channel, he found that 85% of all meteorologists feel that current global warming is controlled primarily by natural cycles. So will global warming end the world in 12 years? Let's investigate that. We have a lot to look at. Well, one thing, we know the summers have been getting hotter. We see it in the news. They have been indeed getting hotter. And that's the proof of global warming right there. That's the underwear in 1860. And as we came up in time, here we are today. And that is about the only proof they have of global warming. But also, winters are also becoming colder across Alaska, Canada, and Greenland. And you haven't heard that in the news this year. I bet you haven't heard a peep about it. Coldest in 40 years. Greenland all the way to Alaska. Fairbanks, third coldest January and February on record. February, greatest Arctic ice extent in 11 years. You haven't heard that in the news either. So the proof of global warming, which I showed you, because it's so cold up north across the border, are they shifting the underwear back? So what's happening? Global warming or global cooling? Or are we having a fight between the two right now? So we're going to talk about the Earth's natural climate pulse. Now, humans and animals require a good night's sleep. If we don't get a good night's sleep, we don't do very well the next day. Well, Earth requires a period of deep sleep also, or it doesn't do well. And this is what happens. Earth's vibrant and awake periods. This is today. Very, very warm period that was preceded by a long glacial period. That was a long sleep period of about 60, 70,000 years. So today we're on the warm awake period, 120,000 years ago, warm and awake, 120,000 years before that, and back 450,000 years ago. Between all the warm awake periods are deep, long sleep glacial periods. This is what the Earth requires. Now, humans often, sometimes, especially as we get older, maybe you need a little cat nap in the afternoon. Well, the Earth also needs a cat nap. Not a long sleep, just a cat nap. So we have shorter cycles. This is today, global warming cycle. That spike there is in the 1930s, very warm, and this is today's spike. So this is the global warming cycle. 230 years before that, global warming. 240 years before that, 230 to 200 years. So those are the vibrant periods during the daytime. Between those, it's much colder. Earth takes a little cat nap. So we can see the difference. There's 230-year cycles and there's 120,000-year cycles. So what controls the sleep cycles, the long sleep cycles, glacial periods? Human activity or natural cycles? I mean, I don't know what humans did back 450,000 years ago, or 300,000 years ago. So let's take a look at the climate pulse technology research that I've done. And it's it's taken from subcycles of the Milankovitch cycles. You can Google that. He was famous for finding the cycles between the Earth, Moon, Sun interactions for the glacial periods. 120,000 year cycles, temperature cycles, the deep sleep. Well, this is the Milankovitch cycles. In the middle, there's the sun, and there's the Earth, and Earth goes around the sun in an elliptical path, where it swings out further away from the sun, in closer to the sun. Every year, in January, it makes the closest approach to the sun, but every 120,000 years, it makes it furthest on the average for a long period of time being away from the sun. So what happens is, for about 70,000 years, 80,000 years, we go to a glacial period when our orbit is away from the sun more. Then when we swing in, we have that warm 120-year cycle I showed you, every 120,000 years. Well, that was where we were 8,000 years ago. That was where we swung in close to the sun. That was the peak of the warm cycle, 8,000 years ago, not today, 8,000 years ago. We're about 8,000 years removed from that on the downward swing headed towards the next ice age. So there's your awake periods again. Remember I said every 120,000 years, there is our warm awake period in between your long sleep periods of the ice age. And that was caused by the Milankovitch cycles. Now let's take a look at carbon dioxide. That's what we only hear about. Carbon dioxide, gonna kill the Earth. Well, human activity or natural cycles on carbon dioxide. First, we have to have a little lesson in the Earth's atmosphere. 78% of the atmosphere is nitrogen, 21% is oxygen, and a little less than 1% is argon. That makes up 99% of the atmosphere. So then we have what we call the greenhouse gas, the gases that they say trap the heat, cause global warming. Let's add in the greenhouse gases. We only have 1% left. Well, 1% is water vapor. That's 1%. So if you add 99% and 1%, you have 100%. Doesn't leave much left over for carbon dioxide. There is carbon dioxide down at 0.02%, just a trace gas. And methane is even worse. Now, because it's such a small percent, when they do their research, they have to change it from percent to what they call parts per million. If you take a piece of air, it's an air bubble, it has 1 million pieces of gas in it. So that's 1 million parts per million. That's an air bubble. Air is made up of nitrogen, has 780,000 parts per million. Oxygen, 209, a little over 209. Argon, 9,340. Water vapor is even higher than argon. Water vapor is a greenhouse gas. So that comes up to the parts per million, 999,800 parts per million. Doesn't leave much for carbon dioxide, does it? About 200 parts per million on the average. Very, very small. Now, if we take that same air bubble, let's take all the other gases out, and we just have carbon dioxide and water vapor. What does that air bubble look like? There's water vapor. And there's carbon dioxide. Big difference. Water vapor is by far the most important greenhouse gas, by far. During glacial periods, the water vapor and carbon dioxide will fall down to 160 parts per million, mean value of it. Both of them fall, water vapor and CO2. During your warm glacial periods, it comes up to about 400 parts per million like we are today. Water vapor also increases and carbon dioxide, both of them increase. So it's not just carbon dioxide. Now, we're at 400 parts per million, they say Earth is dying because of it. You think 400 parts per million is harmful? Do we know? Well, greenhouses try to keep their carbon dioxide levels at 500 to 1,000 parts per million. That's because plants love it. It's fertilizer. The plants take in the carbon dioxide, and it's a great byproduct. What do you think they give off? Oxygen. Boy, did we need that. Now, when the dinosaurs roamed, carbon dioxide was even higher, 1,000 to 1,500 parts per million. That's really up there. They had big, robust plants, big animals. One reason they had big animals also is oxygen was 31%. Today, we're down to 21%. We're becoming oxygen starved. And one reason is because the carbon dioxide is much, much lower, so the plants can't produce as much oxygen. So we don't know what the optimum level is of carbon dioxide, but it certainly looks like 300 to 400 parts per million is not that bad. Now, how do we get the historical measurements? Because we have a problem in this also. What they do is down in the Antarctic, there's a lake called Lake Vostok. It's about 13,000 feet deep ice. That's a lot of ice. The ice down at the bottom is 500,000 years old. So what they do, I talked about the air bubble and the gases in the air bubble. Well, if you take a piece of ice down, it gets older and older as you get down lower. You take a piece of ice and you can examine the air bubbles in there to see how much carbon dioxide you have, how much other things, and determine. It's an approximation. That's why they call it proxy data. That's their ice core. And then they take a slice off the ice. And that slice, not very big, that can cover anywhere from 1,000 to 4,000 years. Because it's under such great pressure down deep, you can't tell 1 year from the next. It's so compacted. So the 1 to 4,000 years, that slice could have up to 35 or more global warming and global cooling cycles. We talked about the 230-year cycles. That's a lot of global warming and global cooling cycles to analyze. So they take that, and if you have 35 global warming and cooling cycles, the carbon dioxide could possibly fluctuate from 200 parts per million up to 400 parts per million, because you're talking about a lot of global warming cycles. So what they do, because they can't determine 1 year from the next, they take a mean value. So the mean value of that would be 297 parts per million. And that's why they say we have never been above 297 parts per million, because it's a mean value over 1,000 to 4,000 years. It's not an instantaneous reading like today. Now, we take the ice core samples, and then they take a look at it. The temperature and carbon dioxide, this is today, going to go back 500,000 years here. This is 450,000 years ago. The red line is temperature, blue line is carbon dioxide. So what happens in a very short period of time, about 7,000 years, come out of the glacial period into the very warm period that I was talking about that we're in right now. And that's the red line, very warm. And you can see the carbon dioxide back of it. Then we go into glacial period, temperature falls like a rock, probably about 10,000 years later, falls like a rock, but look at the carbon dioxide still up high. Now, why is the carbon dioxide up so high and the temperature falling? I thought carbon dioxide caused global warming. How can the temperatures drop? And on the next cycle, same thing, warm up quick, just a matter of 5,000 years or so. And that's where they said we get up to 298 parts per million, but I contend that there are spikes in this. Look at the carbon dioxide spiked about 10,000 years after the temperature. The carbon dioxide keeps going up. It's like today, we're 8,000 years removed from that peak temperature right now. So our carbon dioxide is supposed to still be going up. And then that cooled down rapidly, but look at that carbon dioxide up so high, temperature falling like a rock. Again, carbon dioxide has no influence. So we'll scoot along to the cycles here. Let's come to the last one. During the past 10,000 years, we warmed up real fast, up to our peak. And that was 8,000 years ago. We hit the peak. And then we're gonna look at it a little bit smaller. This was 10,000 years ago, came out of the Ice Age. And then 8,000 years ago, we had a very warm, tremendous warm period, 7,000 years ago. 50% less ice in the Arctic than today. And then we have these cycles that go about every 1,500 years where it cools down, warms up, cools down, warms up, cools down, warms up. This is 1,000 years ago. This is today. It was warmer 1,000 years ago than today. That's when the Vikings settled Greenland. They were able to do it, then they had to leave around 1200 AD, got too cold again. But you can see we're on a downward trend because we're 8,000 years removed from the peak of the temperature cycle. This is what the sea levels did during that time. This is 15,000 years ago. And this right here is about 8,000 years ago. Sea levels came up real fast. About 6,000 years ago, it peaked out. Total rise, 383 feet. Today we're at 360 feet. It was 23 feet higher 6,000 years ago than today. And all we hear about is sea level rise. It was higher 6,000 years ago. Now that we know what controls climate cycles every 120,000 years, what controls shorter cycles? These are the little nap cycles I was talking about. I'm going to take an afternoon nap every 230 years. Well, it's Earth, Moon, Sun climate pulse cycles is what it is. We showed where the Earth revolves around the Sun, elliptical path. Well, the Moon goes around the Earth in an elliptical path also. There's the Moon, there's the Earth. When it's the furthest out from the Earth, that's called the apogee, and you have less gravitational tug, the lower tug, and the lower tides in the ocean. And so it revolves around the Earth, and it comes around, that's the apogee. Then when it comes around, it has 4-year cycles where it swings in very close to the Earth. When it's very close to the Earth, it's called the perigee. The gravitational pull increases by 30 to 40%. That's a pretty good increase. That's on a 4-year cycle. Well, if we bring the Sun in play, we have the Sun, Moon, and Earth in straight alignment. This is called a perigee-syzygy. Gravitational pull increases by 44 to 47%. This is about a 4-year cycle. This is why sometimes you hear about coastal flooding when you don't even have a storm. This is what's doing it. That's how strong the Moon is. So you have the full moon. Ooh. We have a full moon. It takes 4 years to go from 28 degrees below the equator to plus 28 degrees above the full moon in the northern hemisphere. So it takes a total of 9 years about to go from northern hemisphere, southern hemisphere to northern hemisphere. That's the strong cycles I'm talking about. The 44 to 47% tug. And the new moon is on the left, And that is just as strong as the full moon. People don't know that. So you've got a great, it's like putting a wrench on a pipe. Just, it's acting like a plunger, pulling and tugging on the Earth's oceans, atmosphere, inner core. And because of that, the Earth's core could actually expand by 1.5 kilometers. That's a lot. That can increase earthquakes, volcanic activity. We're going to be talking about something about that later. And like I was telling you, the tides. We have a 12-hour regular lunar tide. Then the 4-year cycle I talked about, 9 years, 72, 230, and the 120,000 year cycle. These all cause variations in the climate. That's just a depiction of the moon as it goes down in the southern hemisphere with its gravitational envelope. Then 9 years later, it's up in the northern hemisphere. Now, to show you how important the moon is, if it was not for the gravitational forces of the moon and sun, especially the moon, you get rid of the moon, and the Earth would go also. The moon keeps the Earth in its proper orbit, proper distance from the sun, proper water. That's how important the moon is. Now we're going to take some of these lunar cycles. This is my research. This is gravitational cycles. The yellow line is the strong gravitational cycles I was talking about. That goes back to about 1000 AD. Red line is the temperatures of the Earth, where it's got you can see some global warming cycles in there. Global cooling, global warming, global cooling, global warming. Now, let's see what these lunar cycles do. The lunar cycle comes down and bases out in 1275, peak of global warming. And then over on the right-hand side of that, 1350, the second peak of global warming. Then when the moon goes up, we have strong, strong global cooling. Very strong global cooling. Next cycle, you can see the moon come down. There's your global cooling, about a 10-year cycle, like the 1930s and our last 10, 15 years. Get over on the right-hand side, and there's the second peak in that cycle. All the global warming cycles typically have two warm peaks, like 1930s and the past 15 years we've had. Then that cycle leaves, and there's your strong global cooling, rapid global cooling. Then this cycle, we came down, that was 1755. It was kind of a shorter cycle in 1800. It left, and we had strong global cooling. Now, our current cycle, the moon came down to the base, that was the 1930s, right on schedule. That was a 10-year spike in temperature. Over to the right, that's where we are now. And that's what the moon is doing now, it's leaving. We're now going into the global cooling cycle. Happens like clockwork. And the white line I just put on here is the solar Maunder minimum. That's where the sun has less sunspots and cools a little bit. And you can see the Maunder minimum right here. That was the global cooling. Right here, global cooling right there. Right here, global cooling was in there. And now the Maunder minimum is going also down, where that means global cooling. So we have everything pointing, the gravitational cycles and the solar Maunder minimum, all pointing to global cooling starting now. So here's the global warming cycles. The global cooling began right there. That was 950 AD or so. 200 years later, global cooling began. 230 years later from that, global cooling began. 240 years later, began. 230 years later, it began. And now, you take the last global cooling cycle began in about 1790, 1794. What's 230 of 1790 to 2020? That's now. So if it's going by the clock, we're going into global cooling. That's why Canada is so cold right now, and I'm going to show a little bit more on that. Now, I talked about those strong 9-year cycles, where it goes very strong up in the northern hemisphere every 9 years. This is the actual cycle plot, 1990, 1999, and 2009. They come about every 9 years. I want to show you how important the gravitational cycle is here. This is the United States temperatures going back to 1880. You can see it was very warm now, 2030s. Gee, that was a 72-year cycle. Remember I talked about a 72-year cycle. But look at all these ups and downs. All those peaks are about 9 years. That 9-year cycle? Think that's a coincidence? Climate pulse cycles, the Arctic. The Arctic and Antarctic is where global warming begins. It begins up there. And it also ends up there, and global cooling begins. The key is up in the Arctic. And we're going to look at the Arctic. First of all, we have our conveyor belt of warm ocean waters. This is off of South Africa. Conveyor belt comes up into the Gulf of Mexico, up the east side of Florida, Cape Hatteras. Then it goes across and makes a loop again, cools down, then it warms up again. But there's a spur that goes up. There's England, Ireland, and Iceland. There's a spur that goes up in there. And we're going to look at that because that's a gateway to the Arctic. So what happens is, I showed you those 9-year cycles. When you have a global warming cycle, what happens is you get a warm plunge of North Atlantic water into the Arctic. This is the Netherlands over here. This is the European Strait, Ural Strait. So it comes up and the warm pool of water circulates around the Arctic, takes it 13 years to cool down, die out, and it's gone. 13 years. Okay, here's the 9-year cycles I was talking about, the strong gravitational cycles. We had a warm plunge of water into the Arctic in 1990, right on top of the cycle. Well, what happened in 1999? That was a warm cycle, a very warm cycle in 1999. Look at that, right on top of the strong gravitational cycle. Then in 2008 was the last one, where we had a warm one. So the global warming cycles, what we have is a very warm one usually, and a not as warm one on either side of it. So 2008, that was our last one. So in 2008, warm water pool came up around, takes about 13 years for it to cool down and fade off. What's 2008 plus 13 years? 2021. Boy, we're starting to see 2020, 2021 show up a lot. So, 2020, Arctic Ocean turning colder, freezing again. And global cooling is now beginning from the Bering Sea of Alaska east to Greenland. This is Greenland. This is what they call the melting days, how many days it melts in Greenland, days in a year. On the left side, where I've got it blinking dashed lines, this is from 2003 up to 2012. You can see the melt days were above normal. But look at what has happened from 2011 down to now. Greenland's cooling down. Cooling down a lot, especially this year. Off of Alaska, this is the Bering Sea in red, there's Russia. After years of poor conditions up in the Bering Sea, good conditions now look normal this year. This is the annual plot of the amount of sea ice in the Bering Sea. The black is the average amount of ice during a long-term period. And it peaks out March to April is where you have your greatest extent. You can see in November you don't have much. The dashed red line here was last year, 2018, you can see is way below normal, way below normal. And 2018 is when you heard it in the news, they had a 2-week meltdown up in Greenland, and it was in the news, Greenland melting. It was only a 2-week thaw. Here we are in February. The extent of ice in the Bering Sea is above normal. Greatest recovery in 11 years, greatest amount of ice. So everything's pointing to cool down. Greenland to Alaska. With global warming changing to global cooling, will the oceans continue rising? We keep hearing these forecasts. 2030, 2050, it's going to be way up there. Swimmers will be way up there in 2050. The IPCC, which is the Intergovernmental Panel on Climate Change, that's where everyone gets their information. They say sea levels will rise during the next 80 years 4 to 8 feet. 4 feet by year 2050. 4 feet. It's going to be some problems over here. Well, there's another organization, rise.org. They go around the cities trying to get them to build dikes and things like that. Their forecast from 2060 to 2050, 20 to 22 foot rise. That's why New York City's trying to build seawalls, and they're all afraid that we're going to have 4 to 22 feet of sea rise by 2050. That's a lot. Well, also the IPCC, this is their temperature projections, about 5 forecasts during the past 15 years, red of their projections, and the actual is down here in the green. So they're wrong every time. So do we want to believe their forecast? Well, let's take a look at why they're so wrong. We talked about the sea level rise. 6,000 years ago, 23 feet higher than today. So it's actually gone down, but yeah, it comes up a little bit during the global warming cycle that we've been having here. That's normal. Okay, so let's investigate it. Well, their 23-foot predicted rise, that actually happened 6,000 years ago. Did they put their forecast out 6,000 years ago? I wonder. They're a little bit late on their prediction. During the past 120 years, though, sea levels have risen 8 inches. They have risen. And that can be a problem. But also know that global cooling is coming. It's starting now, and it's going to come in big time in 2024. So what will happen with the sea levels? Will oceans continue to rise, as the forecasts say? Are we going to have a coastal flood disaster? Is that the disaster I'm talking about? Everyone's saying no. Okay, I showed you a map earlier. Here's the United States. This is in February. This is a computer model where the green, especially the purple, is the real cold air from Alaska over to Greenland. It's been sitting there all winter, having a very difficult time getting down to the United States. Typically, we get bursts of cold air, but it really didn't happen this year. Why? A lot of meteorologists are saying, why? Well, one reason is you look at the oceans. Here's the United States. The orange and red, that's all above normal, well above normal ocean water temperatures. And you can see that just about around the whole world. The oceans are extremely warm. And that's tending to change the weather pattern and block the cold air from coming down. So we have to cool the oceans to get global cooling going. So how are we going to do it? 3 ways. One way is global cooling. That's coming. So we know that's coming. It's waiting. The freezer door is up there. It's got the cold air, just waiting to open the freezer door and let it fall. But we have to cool the oceans. Second way is, and I'm going to show you a depiction of it, El Nino in 2022 and 23, followed by a La Nina in 2024. And I'll show you what a La Nina does. A typical El Nino, this is the Pacific Ocean, where the ocean water, that red says very, very warm along the equator, much warmer than it is this year. Very warm. That changes the whole atmospheric circulation. When we have an El Nino year, it's quite warm in the United States, a lot of storms. The opposite is what we call a La Nina, where the water turns cold in the Pacific. A La Nina. So we're going to take a look at that 2024. Are we going to have that happen? And that will help to open the floodgate. Third way is for ocean, warm, cool cycles. There's cycles in the ocean. Can we tie that in also? This is the ocean cycles. The red is a warm ocean cycle. We're in a warm phase of the ocean cycle. Look at that. It happened back in the 1940s, back 1870s. We can see the warm cycles going back. That's in 1540. You think human beings did that in 1540? Did we cause all these warm ocean cycles? We've been told we do. So we're looking at this. What happens, they alternate between warm and cool. The warm cycles, like we're in now, the ocean expands and sea levels rise. When the oceans are in a cool cycle, sea levels actually contract. The seas contract a little bit and sea levels can go down. So we can see we're right on the edge of falling off that cycle. And I say it's going to do it in 2023, 24. So let's take a look at that area. The last 2 cycles here. Okay, this is the sea levels since 1880, going up to now. During a warm phase of the ocean, 1930 to 1960, the oceans went up 2.8 inches. That's a pretty good rise in only 30 years. In the second warm phase, 1980 to now, it's gone up 3.1 inches. That's a lot, 6 inches gone up during those 2 warm ocean phases. Well, we had a cool phase back in 1900 to 1930. Oceans only went up 1.2 inches during a cool phase. Didn't go up much. We had a cool phase back in 1960, 1980, went up less than 1 inch. So you can see the big difference between a cool phase in the ocean and a warm phase. And we're heading towards a cool phase. Since 1880, we've had 2 cool phases. The oceans only went up 2 inches. 2 warm phases went up 6 inches. That's the big difference between cool and warm, total of 8 inches. But cool phase, I have it boxed off because it doesn't go up nearly as much. Well, my prediction, 2025 through 2065, maybe even out to 2100, we're going to be a cool ocean cycle coming in 2024 through 2065, a cool ocean cycle during the period. Ocean levels, I expect to go down 1 inch. Due to that. Global cooling is coming in. That will stabilize ice melt, but we still may have a 1 inch rise. So overall, 0 for a rise. Compare the predictions, I'm saying 0. IPCC says 4 feet, rise.org, 22 feet. So they're not even looking at the warm phase, cool phase of the oceans, and they want to continue to believe that global cooling is never going to happen again. Now we're getting to the unexpected climate change disaster. If the climate disaster is not global warming in the world in 12 years, If it's not that, what do we think it is? And it is not sea level rises. That's not going to be the climate disaster. And it is not carbon dioxide. Water vapor is much more powerful, and we need carbon dioxide. So what is the unexpected climate change disaster? Well, it is partially global cooling. And, any guesses? Volcanoes. They're monitoring several supervolcanoes that have been dormant for 160,000 years. Super. And I'm going to show you the difference between a super and a regular. Hurricanes are classified category 1 to 5. Major hurricanes are 3 to 5. Volcanic index, they call it VEI, goes to 1 up to 7. So what we're going to look at are 7s, and the supervolcanoes are 7+. But I'm mainly worried about just the 7s, but they are looking at 7+. So where are they looking at the 7+? One is in Chile. They say it's already at the critical pressure point, possible eruption, be the first time in 500 years. Second big one, Indonesia. Russia is also monitoring one, and they say it could have catastrophic consequences. Iceland, of course, they have a fear of one waking up. And there's always Yellowstone. Now let's take a look at volcanic activity and global cooling as it's tied into the gravitational cycles. Because gravitational cycles, I've shown you, that they change dramatically as we go into global cooling. And it can change. Earth can bulge by 1.4 kilometers, and we can have more volcanoes and earthquakes. Okay, there's our global warming cycles and cooling cycles. This big red one was a 7 volcano back in 946 AD. It probably caused what we call a year of no summer. And I'll describe in a little bit what a year of no summer is. Then we look as we go into the global cooling cycle. There's another 7 that they say might have triggered the little ice age. That probably caused a year of no summer. Then here's a big flashing one here, the Ringatudo in New Zealand. That definitely had a year of no summer. Then we had some coming down these global cooling cycles, and most recently had a flashing one here. This is in 1815, Tambora, down in Indonesia. That was a 7, caused the year of no summer in 1816 and 17. And what I wanted to show is, here we are now coming into global cooling, and I expect somewhere between 2030 to 2040 that we will see a VEI 7 or greater tied into the global cooling. This is God's world in 12 years, not burning up, but more ice and snow. Year of no summer in 1816, caused by Tambora. And is it coming again in 2030 to 2040? 1816, they had killing frost every month of the summer from Maine to Maryland. Doesn't fare well for your crops. Yellow snow in Europe. Potato and rice crop failures, Ireland. That started the big potato problem. And they had rice failures over in China. Next 30 years, 1/3 of Europe perished. Some of it was through famine, disease, and civil unrest. We only had 1.2 billion people on Earth at that time. We have 8.2 billion now. Global cooling is much more dangerous than global warming will ever be. Next 50 years, global cooling will cause shorter growing seasons. crop failures, food shortages. We saw crop failures this past fall in Idaho, Montana, up in Alberta and Manitoba in Canada. Early snow and frost, they lost a lot of their potatoes, corn, soybeans. That's just one section. So if we get when this big time global cooling comes in, it's going to be worse. Remember I said population 1.2 billion in 1816. Now we have going to have 8.2 billion in 2030 trying to feed them. Probably see population migration. So if you mix in a historic volcanic eruption, even plain global cooling, we're going to have food shortages. We're going to have problems. We're going to have years where we don't have enough food in the world. Even in the Bible, it talks about 7 years of grain. We don't. In cities, they have one day of food, maybe, those people. Now, if we mix in a historical volcanic eruption, which is very likely, we could have a possible year of no summer. Major crop failures, and I mean major. Major food shortages. Major civil unrest, and I mean major. You're going to have countries against countries. Countries seeking food, energy. The United States needs to plan. We must have strong borders, strong military. Not rely on other countries for food, other items, and medicine.
Yeah.
Now, I started this all off by saying government grants created most of this mess about global warming, about man causing global warming. That was a government grant system, pouring out money to the universities, and they just fed on it. And they just, well, they had to keep putting out their literature on it. So what President Trump needs to do is drain the grants and bring in grants for natural cycle research. Climate change, the truth. Okay, do we have time for questions? Or? Thank you, sir. Yes, sir.
Where's Antarctica in all this?
Antarctica right now has its greatest ice extent in a long, long time. There's only one portion of it that has a meltdown. That's due to undersea volcanic eruptions. The rest of it's cooling down and more ice extent. So it's coming. Writing is on the wall.